Okay. So there are these reactions called oxidation and reduction reactions. Okay, oxidation and reduction. In acid base that we just talked about, that is gain an H, lose an H. In oxidation and reduction, that is gain an electron or lose an electron.
Oh, wait, oil. Oh,
Oil rig.
that one.
Where'd you get that? Bio?
Bio.
Yeah. All right. So gain an electron, lose an electron. Now, you guys have all seen some of this. At some point, you saw somebody said, "Let's throw sodium in water." Either you saw it in a video, you saw it in a demo, you saw it sometime. They probably didn't give you any sodium to throw in water because it can be exciting. All right. Why? You've seen it, yes? If not, I'll show you a video. But the idea is the sodium, solid, as soon as it hits the water, starts, you see bubbles and all this foolishness. Because what's going on is the sodium is turning into sodium ion. All right? The other thing that's happening is some of the hydrogen ions or some of the waters are turning into hydrogen gas. Okay? So the two half reactions, if you will, which we'll talk more about later, are hydrogen turning into hydrogen gas by gaining an electron, and sodium turning into sodium ions by losing an electron. You see it? So metals can turn into ions. And this is happening all the time. Yes, sir?
So why does that cause enough energy for the explosion portions of
Okay, later we'll talk about exo and endothermic.
okay.
And it's an exceedingly exothermic reaction. Just this is exothermic, and it gives enough energy to activate the reaction of hydrogen, so it causes a secondary reaction. But later.
Right.
Okay, but thank you, that's an excellent question. And later I can get really into depth, and by the end of the year you should be able to answer that easily. All right? Now, so some metals react really easily with water, like sodium and lithium and all those alkali metals. All right? If you go a little further down the table, I've got to show you, I saw something, magnesium was already on fire and they threw water on it. That was exciting. That was really stupid. Okay, so these guys, all that first column, second column, they oxidize easily. The oxidation of metal. You've seen that. Did anybody when you were a kid leave your bike left out when in the rain? And no, I didn't, because my mom would have killed me. No, but what happens if you leave something out in the rain? It rusts. So you get a little further down here, you got iron, and some of those will oxidize. There's a secondary reaction because they combine with the oxygen in the air. So the half reactions are your iron bicycle reacting with oxygen. The iron becomes iron ions, and the oxygen becomes oxygen ions, and then they go together and make rust. You see it? So what's happened to the iron? It's lost electrons. True? And the oxygen has gained electrons. So it's reduction oxidation. Now, if you look closely at my finger here, I've got on a ring. Yet, this ring has been around for 24 in October, 24. Don't tell my wife I forgot. All right, 24 years, all right? And it looks pretty good still. Why? Nope, I never polish it.
Is it gold?
It is gold.
Because gold doesn't corrode or rust.
Right. Gold doesn't oxidize easily. Gold does not oxidize hardly at all. And literally, they opened up King Tutankhamun's grave, and they shined a light in, and the gold from Lamé that was on his tomb shone back at them after over 2,000 years.
And then they got cursed.
But that's neither here nor there. All right? So gold does not oxidize well. If you come down, there's this thing called an activity series, which says that some things react easier than others. At the top of the reaction up here is sodium, lithium, come down further, magnesium, come down further, copper, come down further, and you've got gold and silver and platinum. They're really, really hard to oxidize. Yes?
Is that why people like them?
Yeah,
Because they last.
because they're shiny and they stay shiny. You know, if I make you know, candlesticks out of silver, every now and again you got to polish them a little bit, but they sit there and look shiny for weeks, months, years at a time. If I make candlesticks out of copper, they turn green.
What about
True.
sodium?
Make candlesticks out of sodium, and then they'll just gradually dissolve away. And then if you pour water on them, it explodes. So that'll be exciting. All right. Now, we tried something yesterday. We poured acid on the copper. The trick was, though, it wasn't the H's reacting, because hydrogen is here. It's less reactive than copper, or more reactive than copper. Copper is very unreactive as a solid. Okay? And so what really was reacting was really the nitrate. The nitrate reacted with the copper. All right? So you had copper reacting with nitrate, turning into copper ions. Now you saw something really cool yesterday. You saw green first, then blue. True?
Mhm.
Anybody watch closely and the solution turned this pretty green, like this lovely green, then it went aquamarine, and then it went to that deep base blue? All right? That's because these guys, copper 1 ions are green. Copper 2 ions are blue. So as it first started to react, some of them only lost 1 electron and you became copper 1, and then you kept losing electrons, became copper 2. Yeah.
So if you leave copper out in the air, will it also go to blue eventually?
Yep. I mean, it would take an incredible long time for it to turn blue out there. Partly because the reason you like the Statue of Liberty to have that green sheen to it, because it forms an oxide layer that actually protects the inner layer. Because that layer of green, as long as you don't scrub away that green is between the air and the copper. Because for the bicentennial of the French Revolution, I think, they polished up and cleaned the Statue of Liberty. And it was sitting out there in the harbor all pretty and copper colored, looked like a brand new penny for about a week. And then it turned green again. All right? Yes.
So the green layer is just copper with one more,
Yeah,
or
one less
electron.
electron,
One less,
backwards,
yeah.
yeah, backwards like everything.
Yeah.
So here's the deal. If I put some copper into a solution of sodium, in other words, if I have some sodium ions, and I put them near a piece of copper metal, the sodium can't take back its electrons. The sodium isn't strong enough to take the electrons from the copper. Okay? Conversely, if I put some sodium and I put some copper ions near that, in other words, I throw some sodium metal and put it near copper ions, the copper ions will take the electrons from the sodium. And you'll see it turn back into copper metal. You'll see it appear. It'll just magically appear. And the sodium will decrease. Okay? So in other words, anything up here will give away its electrons to anything down here that doesn't have them already. So if I had silver ions, gold ions, platinum ions, they would take the electrons from everything up here. These metals. They would strip the electrons right off the metal. Make sense, Hannah?